Over x minus 3, exactly, right. That is the slope between those 2 points. That's it, right there. Now here's the thing. When we were finding the instantaneous rate of change, so the slope of the tangent line, the instantaneous rate of change, we anchored the point at the target point, and we brought the other one closer, right? So we kept on doing repeated secant lines, right? So we kept on making x closer and closer to, x kept on getting closer and closer to a. So what's the slope of the tangent line? The limit as x goes to a of f of
A.
which is a in this case is 3. So it's just f of x minus f of 3 all over x minus 3. Done. That's it. That's it. All you're doing is you're anchoring one point, and what are you doing with that x value? You're bringing the x value closer and closer to a. In this case, the a value was 3. Do they tell you what the function is? No. They tell you to write an expression. Write an expression. If you're writing an expression, are you coming up with a numerical value? No, you're writing this expression. It's okay if there's no function. That you're going to set this up many times. You will, in future problems today, be given a function for f of x that you plug in and evaluate the limit with it. But you're not. Can you go any further than that? Is there anything to factor? No, there's nothing you can do. That's where you are right there. Those are the x values. A point is an x and a y value. So what's the first one? F of a. And what's the second one? Comma. Exactly. Those are the 2 points. So how do you find the slope between 2 points? F of a plus h all over a plus h minus a. Does that simplify a little bit? Yeah, a little bit. A plus h minus f of a all over what? All over what? H. This is the exact same quotient that we did before. The exact same thing. Instead of x moving to a, h is going to a plus h minus a is h. Instead of x going to a in this case, instead of moving x to the a value, you have a plus h getting infinitely close to a. Marcy, this is important. So instead of x going to a, what's happening to h? It's going to 0. Who said that? It's going to 0. Look, instead of x moving to a, we have this distance. It's called a plus h. And we're making a plus h closer and closer to a. So what's happening to h? It's getting closer to 0. This is a different way of writing the exact same thing. So instead, so it says write an expression for the instantaneous velocity. It's going to be the limit as h goes to 0 of f of a plus h minus f of a all over h. This is just another way to write the exact same thing we just did. For example, if we go back up here, you see this, everybody? We have x going to 3, right? This is the exact same as the limit as h goes to 0 of f of x, sorry, f of h goes to f of 3 plus h minus f of 3 all over h. These are the same. These are the same. Usually you default to one of them. You'll become more comfortable with one of them. Some people become more comfortable with this form, some of them this. Do they give you the exact same thing? Yeah. Yes. They give you the exact same thing. Instead of x moving to a, you have a plus h getting really, really close to a. So what's happening to h?
So
it's going to 0.
Over h if h is going towards 0?
Well, it depends on what the function is. It simplifies, things cancel out. Sometimes one is more easy to use than the other depending on what's given to you. But in this presentation, it specifically set you up for this because it asks you what's the average rate of change between these two things. It set it already up with a plus h. Okay, you wanted to see 3? Yeah, this is good. This is a great one, I think. How'd you guys feel about number 3? Okay, you have to have an opinion. This isn't American democracy where you get to decide if you vote or not. It's mandatory. Find an opinion. Buy one. That's fine. It's good that you stated that.
I mean,
it's asking you for the, it's estimating the slopes of each of these, right? That's what it's asking you to do?
You find it using the points that they give you.
You estimate it just by looking at it.
yeah. A simple way.
Guys, one thing that bugs the crap out of you guys, I know, is that when they don't give you a function, kids get really set in their ways that they have to have an exact answer. you can answer this question concretely without getting an exact answer. Consider the slope of the given curve at each of the 5 points. Let's just look at A for 1 second. A, what can you tell me about the slope of that line? What's one concrete thing you can say?
It's negative.
Negative. What's the slope here?
Positive.
Positive. What's the slope here?
0.
0. What's this one? Positive, and this one is?
Negative.
So this is negative more, this is negative less, this is positive less, and this is positive more. So it says list these 5 slopes in decreasing order and explain your reasoning. So in decreasing order, so what's the greatest slope? Oh, actually, you know what? I'm sorry, I was totally wrong here. This is not positive more and less, right?
Yeah.
I'm totally wrong. This is negative less. This is negative more, because it's steeper there, right?
Yeah. That's
It's
fine.
You're
more when it's
absolutely-
steeper, right?
What?
It's more when it's steeper.
Yes, that's what I mean, a bigger one. I'm using bad language, I understand that. But so if you put these in order, what's the steepest one? D. What's the D, E, C, A, B. Exactly. There it is. That's what they're asking for. Are they asking for the exact values? No. Could you theoretically estimate these? Well, you don't even know what the scale is on the x and y axis, so it's hard. But assuming it's the same scale, could you like take out a ruler and estimate what the slope is? You know, this one looks like, I don't know, 1. This one looks like 2. This is 0. And if this is symmetrical, this is going to be -2, and this is going to be -1, right? You can estimate it, but the point is you definitely know it's negative in one place. You definitely know it's positive in the other. And it looks at C, it's supposed to be 0. That's all they're asking you to do. Conceptually understand what a derivative is. That's it. Okay, so we have this, so we graph it. Does it look nice and curved?
Yeah, something.
Does, okay. So this right here, so when they say, I'm going to put this in here, so this represents, just so you can remember, it's -1 to +1, 0 to 2. And this is y equals e to the x. Yeah, so what happens as you zoom in further and further on this? It looks straighter and straighter. So what you're doing is I think you're zooming in right here, right? The line will look straighter and straighter. So let's just go to the furthest one. What is it? -0.1 to +0.1, right?
Yeah.
And let's go back there. So -0.1 to
Positive.
0.1, and then it's 0.9 to 1, right?
0.9 or 0.9.
I think it's 0.9 to 1, right? 0.9 to 1.1. Thank you. So if you graph this, it looks straighter and straighter. You're just zooming. If you look at a curve and you zoom really close to the curve, eventually it'll start looking pretty flat because you're getting closer and closer to looking at the instantaneous rate of change, which is linear. So as you zoom in here, this right here is the same exact thing, except we've zoomed in further. So where we zoomed in here, we're looking at it right here, right? This is what we're looking at, and now it's going from -0.1 to +0.1 and 0.9 all the way up to 1.1. It looks more linear. Does that one make a little more sense now? Do the limit if you do it. So now what do you plug in for f of x? Yeah, the equation, exactly. So you have the limit as x goes to -3. What's f of x? X squared plus 2x. And you're subtracting. What is f of -3? It tells you already. Hint. What's f of -3?
3.
Yeah, there it is, all over -3. Now this is the limit. Can you plug in -3? No. Oh,
X plus 3. Isn't that X?
yes. What's the numerator factor into?
X plus 1, x minus 3.
There you go, over x plus 3. Now what cancels? Nicely. The x plus 3's cancel. That's really happy. And you end up with the limit as x goes to -3 of x minus 1. What's that equal? -4. So do we have the slope? Now it says using equation 2. So this one right here was definition 1, right? What was equation 2? The a plus h thing, right? The thing you need to remember, let's just remember the exact raw formula, which is this. The limit as h goes to 0 of a plus h minus f of a all over h. So now we fill in the blanks. We know what f of x is. What was it? Remember, f of x is equal to, what is it? 2x squared plus 2x? So now it's just plugging things in. So when it says f of a plus h, where do you plug in the a plus h? in for x, exactly. So you end up with a plus h squared plus 2 times a plus h. What is f of a? What's f of a?
Plug in A.
It's a squared plus 2a. Do you see what I just did there? What is this right here? This is f of a, and this is f of a plus h. Are we okay with that? What do we do now? One word. What do we do now? One word. Nope. Simplify. I guess you could say expand and simplify. That's fine. So you have the limit. So you have the limit as h goes to 0 of, you have to multiply this out at this point. You have to. What do you end up with? A squared plus 2ah plus h squared plus 2a plus 2h minus a squared, sit down, plus 2a. All over? All over h. Can we cancel some stuff out? I hope. What cancels here?
A squared and 2A.
The a squareds cancel, right? And the 2a's cancel. And what are you left with on top? Limit as h goes to 0 of what?
H squared 2A.
H squared plus 2ah plus
2A.
2h all over what? So we took care of those three over h. What factors out of the top?
H.
Limit as h goes to 0 of h times h plus 2a plus 2 all over? What cancels?
H.
So you have the limit. You have to say h a lot and it sounds weird. H plus 2a plus 2. Is that correct?
No, I got it. Negative.
No? Did I do something wrong?
Yeah.
You can plug in the
You cancel the 2A.
Ah, what did I cancel wrong?
Yeah, that shouldn't have canceled. It should have become 4.
Oh!
Negative. That was negative.
These right here.
It
They're,
becomes
they're
4A.
negative. It should be negative because when you.
Okay, hold on. All of you speaking at once. So please do number 6 right here. And I'll write down the definitions for you. Definition 1 is going to be the limit as x goes to a of f of x minus f of a over.
It's minus A.
And this one is the limit as h goes to 0 of f of a plus h minus f of a all over h. I will give you that. You don't can pause for a sec. Thank you. So if we do this out, the first one here, it's going to be the limit as x goes to what? To negative 1 of x cubed minus negative 1 all over x minus negative 1. So it's the limit as x goes to negative 1 of x cubed plus 1 over x plus 1. Now many of you now remember that that's the same thing as you can factor the top. It's x plus 1 times what? X squared minus plus 1 over x plus 1. And this is magically awesome because what cancels?
X plus 1. X plus 1.
Yeah, and you're left with something. What can you now do with this limit? What can you do? You can do direct substitution. And you end up with what? 3. Okay, the second method is a little bit more annoying because it actually demands that you do a little bit more algebra. Did it work? And it finishes. You're doing the limit as h goes to 0 of f of a plus h minus f of a all over
H.
h. In this case, it's kind of a pain because what is f of x in this case? X cubed, right? So when you do this out, you end up with a plus h cubed. But in this case, what is a?
A is negative 1.
A is negative 1. So you really want to substitute that in now. It helps a lot. It makes it easier. So it's the limit as h goes to 0 of h minus 1 cubed minus, what is f of a? When you plug in negative 1 into this, what do you get?
Negative.
All over h. So what are you going to have to do? You have h minus 1 times h squared minus 2h plus 1, right? And this is all over. And it's the limit as h goes to
0.
you have to keep multiplying it out. You have to keep multiplying it out. So you multiply through by h, and you get h cubed minus 2h squared plus h minus h squared plus 2h minus 1 plus 1 all over h. What cancels up there? The minus 1 and the plus 1 cancel. Anything else cancel?
Nope.
Nothing, but you get that 3h. So it turns into the limit as h goes to 0 of h times h squared minus 2h plus 1 minus h plus 2, right? All over what?
Over H.
Thank you. Over h. Thank you. What cancels? This is nice because now what can you plug in? It's what's it going to equal? 3. Because this is 0, this is 0, this is 0, but which leaves you with 1 and 2 is 3. Does that match what we got before?
Yes.
Should it match what we got before? Yes. So the moral of the story here, sometimes, guess what? You're going to have to do some multiplication that isn't necessarily too much